Drake equation lists the different factors we need to know to predict n, the number of intelligent, detectable civilizations in our own Milky Way galaxy. It includes factors like how many stars have planets, and how often will life become intelligent, and how long a technologically advanced civilization might last.
And if you put in scientists' judgment the most plausible values for the factors in this equation, n equals 10,000 detectable civilizations in our galaxy.
10,000 intelligent civilizations, just in the Milky Way alone.
That's Frank Drake's best bet, but it's far from conclusive. If you plug different values into the equation, then it's easy to come up with other results. Anything from 1 billion civilizations all the way down to 1, ours. For a long time, the values for most of these terms were unknown. The Drake equation was something of a list of mysteries, leaving the equation unsolvable. But in the last few years, our knowledge of cosmic origins has been growing exponentially, and we're on our way to solving at least some of these mysteries. Take just one term in the Drake equation, the percentage of stars, other suns, that have planets orbiting them.
If alien life is anything like us, it needs some solid ground to call home. And so, we want to know how many planets are out there. Depending on who you talk to, our sun's got 8, maybe 9 planets circling around, including Earth. Until recently, we haven't been able to see any planets beyond our own solar system. None at all. The problem is, planets in deep space are rendered practically invisible by the blinding light of their suns. That's the challenge for the handful of scientists trying to track them down. The team of Paul Butler and Jeff Marcy started their quest in the 1980s with little more than their own enthusiasm.
We started off with virtually no money at all. The first proposal I wrote for a grant to fund our planet search was for $930 for the whole year.
When Jeff and I started the planet search back in the fall of 1986 at San Francisco State University, to say we were unknown is to overstate it. We were sub-unknown.
The young astronomers were banking on an experimental technique they believed could scope out planets by focusing on the stars they orbit.
As a planet orbits a star, the planet pulls gravitationally on the star, making the star wobble. You can tell a star has a planet, or more than one planet, just by the motion of the star, which ought to be stationary, but wobbles due to the pull on it by the planet.
The star's wobble, created by the gravity of orbiting planets, is so subtle, Marcy and Butler can't see it directly, so they use a special technique.
It's hard to detect this motion directly, so we thought we would use the Doppler effect. As a star moves toward you, the light waves get compacted, and that means they get shifted toward bluer colors. And then as the star wobbles away from you, the wavelengths of light get stretched out, and that is interpreted by our eyes as redder.
Even using the Doppler effect, the only planets we can infer would be ones with tremendous mass. Marcy and Butler were confident that they had the best method for hunting down big planets and hoped they'd be the first to succeed when the unthinkable happened. A team of Swiss astronomers beat them to the punch. The first planet outside our solar system had been found, but by someone else. Most astronomers were skeptical. Although the planet was massive like Jupiter, the Swiss discoverers claimed it orbited its star, 51 Pegasi, in only 4 days. This seemed impossible. Earth takes 365 days to orbit the Sun, and Jupiter takes 12 years. Marcy and Butler felt certain there must be some mistake.
Almost every year for the last 100 years, somebody's claimed to have found the first extrasolar planet. And the one thing all those claims had in common was they were wrong.
And luckily, Paul, Butler, and I had telescope time the very next week. And we thought, well, we'll just go up and take data on this star 51 Pegasi and show that it probably doesn't really have a planet at all.
And when we got back and we analyzed all the data, we were stunned. We were stunned because their claim was right. There really was a Jupiter-like planet in a 4-day orbit. We were stunned because this was the first legitimate real planet ever discovered. And that furthermore, that these planets could be much stranger, much more bizarre than any theories that had ever been conjured before.
Marcy and Butler had spent years looking for massive planets, like Jupiter, far out from their stars, with long, slow orbits. Now that they realized that big planets can make a complete orbit in a matter of days, they began to wonder, had they missed something? The evidence for new planets might be buried in their old data, but to find it, they'd need hundreds of hours of computer time.
And we only had 2 little computers. So we ran around madly, trying to borrow and in some cases subverting our colleagues and stealing their computers so that we could analyze all of this backlog of data.
They worked furiously around the clock for weeks, recrunching 8 years of data.
I was literally in my office 24 hours a day for about 6 months, reducing data.
Some nights, hardly sleeping at all and just making sure the computers were all running. God forbid the computer should sit idle when we could have been finding planets with it.
But the marathon was worth it.
Within a month and a half of the discovery of the planet around 51 Peg, we found 2 planets sitting in our own data, right there on our computers. The planet around 47 Ursa Majoris, spectacular, and then the other planet around 70 Virginis.
Planets were finally being found, but they were huge gas monsters circling close to their stars, often in highly elliptical orbits. Scorching hot or with unstable climates, they were friendly to neither life nor other Earth-like planets.
Any poor Earth that got in the way would be slammed to death. I mean, a little Earth anywhere nearby a Jupiter would get slingshot out of the system, or maybe the Jupiter would hit that Earth, then probably spell doom for any life on any terrestrial planets in those systems. And it really begs the question, is our solar system with its nice, neat phonograph groove-like orbits some kind of wacky weirdo in the universe, or are there others like ours?
In addition to its neat round orbits, our solar system provides particular shelter for Earth, thanks to the presence and position of Jupiter. Jupiter's enormous gravity throws asteroids and comets off course, slingshotting them out of the solar system. Without this protection, these cosmic missiles would frequently smash into Earth and destroy life as we know it. So if Marcy and Butler want to find Earth-like planets, first they need to find Jupiters more like our own.
The holy grail for us is to find a sun-like star that has a Jupiter as far from it as our own Jupiter is from the sun. That Jupiter would protect any Earths that